Hi everyone. Alright, for this lesson I'll show you the inverse variation. So let's say we have the equation y equals k over x, right? And we define k to not equal to 0. So k can't equal to 0, right? So whenever you have something like this is known as an inverse variation, right? Okay, inverse variation. And the constant of variation is k, right? So k is the constant of variation. For this inverse variation. Okay, so the constant of variation for an inverse variation is k, and the equation is y equals k over x, where k is not equal to 0. Alright, let's say y varies inversely with x, right? So that's given, okay? And I tell you that y is equal to 5, say, and then x is equal to 2. And I want to find the inverse variation equation. Alright, so we want, what do we want? We want the inverse variation equation. Okay, and how do we do that? Well, we're gonna use the equation I showed with on the last slide, y equals k over x. Okay, and I'm gonna plug the known values. All right, so we know y is 5, so there it goes, and we know that x is 2, right? So plug that in there. Okay, and the equal sign will be here, and the k will be the numerator, and there we have it, right? So now we just need to multiply both sides by 2, right? So let me do that real quick. So multiply this side by 2, but this is an equation, so you do to one side, you have to do the exact same thing to the other side, right? So here we go, right? So now what happens? Well, this 2 and this 2, they cross out, they go to 1, so you're just left with k on the right. Okay, so this becomes just k on the right, and you have 10 on the left, so k is equal to 10. So now we can write our inverse variation equation. Okay, so let's make some room right here. Right, and our inverse variation equation will be of this form here. You can think of it like this, but replacing the k that we found right here. Okay, so here we go. Here's my little spot. This will become y equals 10 over x, and that's our inverse variation equation. Okay, and we're done, and we're happy. Alright, so let's do this real world example here. We know that weight and distance vary inversely. Alright, so what that means is this: the weight needed to balance a lever varies inversely with the distance from the fulcrum to the weight. So let me draw this little example here. So let's say we have this lever, right? And we have the fulcrum somewhere over here, right? So this is the fulcrum, right? And here's your lever. And let's say we have this animal on one side. See if we can make out what that is. right? It's supposed to be an elephant. I tried. All right, so we have this elephant on the right hand side, and the weight of the elephant is 2,000 pounds. Okay, so it's a big elephant. All right, and I'm standing over here. This is me, right? So I'm kind of nervous. I'm standing right here. Okay, that's me, and I weigh 150 pounds. Right, so my weight is 150 pounds. All right, and let's say we don't know the distance here, so let's call that x from my end here all the way to the fulcrum, which we'll spot it right here. All right, but we do know that the weight of the elephant is 2,000 pounds, and that the weight, the distance here, let's just say it's 5 feet, right? So the distance here is 5 feet from here to here. Okay, and I want to find out how far do I have to stand, right, on top of the lever to balance this lever here on the fulcrum, right? So we know that weight and distance vary inversely. So let's write that down real quick. We know, so let's put a star here, right? You know that weight, well, we know that weight and distance, right, vary inversely. Okay, oops. Okay, so that's key there, right? So now we can set up an equation, right? Here goes. So let's say my weight, right, times the x, okay, is equal to the weight of the elephant times the distance, right, that the elephant is from the fulcrum, which is 5 feet. Okay, so when we do this out, 2,000 times 5, we get 10,000, and over here we have 150 times x, and then all we need to do is divide both sides by 150, divide this by 150, and oops, this will cancel, and x will come out to be approximately, so this is an approximation, approximately 66.67 feet. Okay, so this tells me that I have to be roughly 67 feet away from this fulcrum to balance this elephant that's 2,000 pounds, and I only weigh 150 pounds. Okay, and so this is our answer here, and I'm pretty happy because I get to balance the elephant. Let's take a look at the inverse variation equation again. Y equals k over x, all right? And I want to find out what the graph look like on the coordinate plane here that we have, right? So let's pick some values for k. Let's say k is greater than 0. All right, when k is greater than 0, when you graph this, it's going to look something like this. All right? So let's say this one, k is equal to 2. So this is k equals to 2. Okay? Right? What if I increase the value of k? Let's say k, so this one was 2. K is equal to 2. What if I say that k is equal to, let's say, 5, right? Well, in that case, it's going to be slightly more away from the origin. So this is k is equal to 5, right? And this, and it mimics on this side too. Alright, so this is k equal to 5. Alright? What happens when you have negative k? Let's say k is less than 0. Let's say k is equal to, let's keep it the same number here, negative 2. Right? It's going to look something like this. So you have to be careful here. The curve does not pass through the x-axis, right? So make sure you don't draw it and make it pass through. It shouldn't, right? So actually, let me erase this, make it a little bit better. Okay, and so this one is k equal to -2. And you might have guessed it, if k is, say, -5, oh, that's probably the same color, we don't want that. Let's try this one here. Say k is -5, it's going to be more like this. Okay, so this is k -5, and over here it's going to be something like this. Alright, so these are the different scenarios for different values of k and what it looks like on the x and y plane, okay? Alright, let's say you have a t-table that looks like this. 2 for x and then 1, and then 4 for x and then a half for y, and then 1/4 for x and 8 for y. And you want to figure out, is this an inverse variation? So we want to know if this is an inverse variation, right? So what we have to do is think of, well, the inverse variation equation, right? The y equals k over x. And if you multiply both sides by x, you'll come up with something like this. xy, because this x and this x, they cancel, is equal to k. So we know that k is equal to xy, and another thing to note is that k is a constant. Okay, this k is a constant. And what that means is that k does not change, right? The value of k does not change. So let's double check here. Let's check the first one. All right, let's do x is 2, y is 1. If I plug it in here, it's going to equal 2 times 1, which is 2, right? Check. All right, let's try another one. Let's try 4 and a half, right? So x is 4 times a half, and we know half of 4 is just 2, right? Check. And the last one there, we have 1/4 with the 8. So x is 1/4, and the y is 8, and you multiply these two, and that gives you 8 over 4, which is just 2, right? As you can see, each time k is 2, right? It doesn't change, so k is constant, right? And if you can find that out, and k is constant for all of the ordered pairs, then you know, then this is definitely, yes, it's an inverse variation. Okay, and we're pretty happy, and we're also done.